Welcome back to another journey into science and philosophy. So far, we've explored time, the cosmos, and even consciousness. But today, we dive into the weirdest world of all, the quantum realm. Here, common sense breaks down. Particles behave like waves, objects exist in two places at once, and reality itself seems to care whether we are watching. In this episode, we'll explore three of the strangest ideas in quantum physics. The double-slit experiment, how particles know they are being observed. Quantum entanglement, Einstein's spooky action at a distance. And the many worlds interpretation, a radical idea of parallel universes. Let's begin with the experiment that started the quantum revolution. Part 1. The double-slit experiment. Imagine you shine light through two narrow slits onto a screen. Instead of two bright stripes, you see a pattern of many lines, as if the light were rippling waves. That's expected. Light behaves like a wave. But then scientists tried the same with electrons, tiny particles of matter. Shockingly, electrons also made a wave-like interference pattern, as if each electron were a spread-out wave passing through both slits at once. Now comes the twist. If you try to measure which slit the electron actually goes through, the pattern disappears. The electron suddenly behaves like a particle, choosing one path. It's as if reality changes its behavior depending on whether it is being observed. You might ask, but what counts as observing? In physics, observation just means interaction with a measuring device. But still, the mystery remains. Why does measurement force the electron to decide? Some interpret this as proof that consciousness plays a role in reality. Others argue it's simply the math of quantum mechanics. Either way, the double-slit experiment tells us the world at its smallest scales is nothing like the solid reality we see. And if that wasn't strange enough, let's move to something Einstein himself found unsettling. Part 2. Quantum entanglement. Quantum entanglement happens when two particles become linked so that their states are connected, no matter how far apart they are. Imagine two entangled electrons. If one spins up, the other instantly spins down. Measure one and you instantly know the state of the other, even if it's light years away. Einstein called this spooky action at a distance because it seemed to violate the rule that nothing travels faster than light. You might ask, does this mean information moves instantly across space? Not exactly. Entanglement doesn't allow faster than light communication. Instead, it suggests that the two particles are part of one shared quantum system, even when separated. Distance simply doesn't matter at the quantum level. Entanglement has been tested in countless experiments, and it always works. It is now even used in developing quantum computers and quantum encryption. So while Einstein was uneasy about it, entanglement is a real and fundamental feature of the universe. But if particles can be linked across space, could entire worlds branch across possibilities? That leads us to our final paradox. Part 3. The many worlds interpretation. Quantum mechanics says particles don't have fixed properties until measured. Before measurement, they exist in a superposition, many states at once. But what does that mean for reality itself? One bold answer is the many worlds interpretation. It suggests that every time a quantum event could go two ways, the universe splits. In one branch, the electron goes through the left slit, in another, the right. Both outcomes happen, just in different universes. You might ask, does that mean there are infinite versions of me? According to this interpretation, yes. Every decision, every random event spawns new branches. In some, you're watching this video. In others, you never found it. Critics argue that many worlds multiplies realities without proof, but it avoids some of the paradoxes of measurement, since all outcomes occur somewhere. Whether or not many worlds is true, it challenges our sense of uniqueness. If reality branches endlessly, then perhaps every possibility is real. Outro. Today, we explored three of the strangest ideas in quantum physics. The double-slit experiment, particles acting like waves until we watch them. Entanglement, spooky links across space. And many worlds, the possibility of infinite parallel realities. Quantum physics doesn't just describe the universe, it challenges what we mean by reality itself. Maybe the world at its core is not solid, but a dance of probabilities, collapsing into certainty only when we look. And maybe, just maybe, somewhere in another branch, another version of you is asking these same questions.